In the previous video, we have discussed the notion of function. What is a function? Now we are going to see, we saw there were different ways to describe a function. Now we are going to see some very important examples of functions. Okay. There is this class of functions called the class of standard functions. Okay. These are built as combinations of the following special types of functions. So first, polynomials. Okay, this is the most basic one. Within the polynomials, the easiest is the linear polynomial. Linear means it's a line. Okay, so it's f of x equals mx plus b. Okay, they are all of this type. M and b are two numbers. Okay. So m and b are given, and x is my input, and f of x is my output. So here, let's do an example. Let's say we want to find a formula for all linear functions such that f of 1 equals 3. Okay. If you want to pause the video now and try yourself, that would be very good. A very good thing for your learning. So we have a template here that is mx plus b. Okay, so let's try out what happens here. So we need f of 1 equals 3, so we need this condition to hold. We need to replace x by 1, all right? And we are set. So we have this condition that m plus b needs to be equal to 3. So this means b is equal to 3 minus m. So then the functions are going to be f of x equals mx plus 3 minus m. Or if we want to make this look nice, we can write m times x minus 1 factor m plus 3. So these are all the functions, all the linear functions such that f of 1 equals 3. Okay, so these are, if we want, you may be wondering why there's a whole family of functions. Well, so if you have this x equals 1, and then 1, 2, 3, okay, what are all the functions that pass through this point? All the linear functions. So they are going to be all the lines with all possible slopes. Okay, so that's the reason why we have a family that depends on one parameter. Notice there, m is playing the role of the slope. Okay, so for each m, you get a different slope, you get a different line. Okay, linear functions are lines. Okay, so this is the easiest type of polynomial. So the second type is the quadratic polynomial. Okay, here the template is ax squared plus bx plus z plus c. So in this case, the graph is a parabola. Okay, then we have, well, we single out the linear and the quadratic polynomials because they are very useful. Then the rest, we just put them in the same bag. So those are the higher degree polynomials. Okay, here we have cubic and so on. Okay, we do that because they don't come so often. Okay, so these are the polynomials. So the second type of functions that we want to talk about are the power functions. Sorry, the second type. So the power functions, the template is x to the power a. Okay. So here you could say, but didn't we do this already? No, we did when a is a positive integer. X to the power a is a polynomial. But I didn't say a needs to be an integer. So a could be, let's say, a quotient, 1 over n, with n positive. Okay. Then actually what I'm looking at is a root. Is the nth root of x. Okay, so if the exponent is a fraction, 1 over n, then it's a root. For example, n equal to f of x is the square root of x. In this case, this is the only case where we don't write the number n, right? Because it's like this is the convention. Okay. But we could also have, did you see that I wrote here positive integer? So you may have thought, hey, why positive? So what happens if it's negative? For example, let's say we only need a equal negative 1. Okay, with these three cases that I already wrote, we will be able to construct any other. Okay, if we have a negative 1 in the exponent, then f of x is actually a quotient, is 1 over x. Okay, and this is the reciprocal function. Okay, so these are the power functions. Then we move on to rational functions. These are a polynomial divided by a polynomial. Okay. So one example would be, let's write something wild. So let's say x to the power 3 plus 3x plus 1 divided by x squared minus 1. Okay, here, beware, the graph typically has asymptotes. We will learn about this later on. Okay, so 3 more to go. So the fourth type is the type of exponential functions. Okay, these functions are of the form a to the power x looks similar to what we saw before, to the power functions, but you see the a being up or down makes a big difference. So these ones, the a must be positive, okay? There are two types here. So if the a is bigger than 1 or smaller than 1. So if it's bigger than 1, then we have an exponential growth. And if it's smaller than 1, then we have an exponential decay. And they happen to be equal to 1 at 0, okay? The picture is a little so in that aspect, but it's okay. The biggest, the most famous here in this category is the natural exponential. F of x equals exponential of x, e of x. This is the number e, okay? We will use this a lot. Now, the opposite of exponentials are logarithms. Logarithmic functions. Okay, these ones we write f of x equals log a of x. This means a, we call it the basis of the logarithm. Okay, so for example, there is one that we need to single out when a equals the number e. In that case, we use the notation ln, that means Neperian logarithm or natural logarithm. Okay. And so we did, yes, and we only need to do one more, that is the trigonometric functions. By the way, logarithms look like this. Okay, so this will be a. The trigonometric functions, they are going, well, we have the direct, f of x equals sine of x, cosine of x, the tangent of x, which is the sine of x divided by the cosine of x. Okay. And then we have the inverse trigonometric functions. Which are the arctangent, arcsine, arccosine. And then the arctangent. We will go over each of these in detail in later videos.